Hmm. Okay, let's see where to start. So you just put a bunch of numbers here. Okay, any number 10, 11, 12, 13, whatever you want to put it. Okay, basically, it is just like it's basically like a table, but then instead of putting rows and columns, you just put it as blank numbers in between brackets. For example, let's say I have uh, two people, and then we have their marks for maths, science, and whatever. Then this guy got 90, 91, 80, 81, and then let's say I want to find the average of for each subject or average for the entire student's grade. Let's say I want to find the average for the math subject. First thing I would do, okay, I want to find the average, but I want to use fully maths. I don't want to like use the table at all. I just want to use fully matrices. Then I'll convert this to a matrix first. So the rows will represent the name of the student, and then the column represents the subject they're in. Okay. So now let's say I want to go and find which one you want to find first. You want to find the average mark for the student or the average mark for each subject. Hmm? Up to you. For the student, okay, fine. The student means we want to find the average of each row. Find the average of each row. We multiply this one by basically just 1 and 1. Okay. So now we will distribute 90 plus 91, 90 plus 91, and 80 plus 81. Okay. And then what do you get? First we find 5 times total first. So it'll be 181 and 161. Okay. So now you have the you have the total mark for each student. So now you want to find the average. You have to divide it by the number of subjects they each took. So both them took 2. So you just have to find the half of this matrix. What is the half of 181? It will be 90.5 and what 80.5. Yeah. So you can also do divide 2. Another way of doing it, divide 2 and then divide 2 is same as times 1 over 2, multiply 1 over 2. It's a very simple example of how you use matrices as well. To do basic calculations. You can use it for one more thing. Let's say you have inventory for Jan and inventory for Feb. Okay, so okay, shop A for pens and pencils. Okay, and this for shop B. So in Jan they had 20, 21. Just put random numbers. Same shops A and B. Pens and pencils. So in this month they stocked up more. Okay, or this is the new stock that arrived in Feb. So now the question asks you to find the total stock of pens and pencils in shop A and B over the 2 months. First thing you do is you convert this to a matrix. So basically you can just add each, you already know, right, to find the total number of pens for shop A, You just have to add the number of pens in January in shop A and a number of pens in January, in February in shop A. Then you get the total number of pens for that shop. But for into matrices, convert it to a matrix first. 20, 21, 30, 31. Then shop for February will be 30, 35, 31, 32. So to find a total number of pens and pencils, okay, you get 50. This will you add the corresponding um, rows and columns. 20 plus 30 is 50. 21 plus 35 is 56. 56, 61, 63. So there are a total. Okay, then you put back the rows and columns. This will be the shop A, the shop B. This is pens and this is pencils. So in shop A, over 2 months, total of 50 pens, total of 56 pencils. Shop B, total of 61 pens and 63 pencils. Or if the so this is an example of using addition for matrices, is adding the corresponding elements up. It's easier to understand if you think of it as why we even do this stuff. So I'm giving you an example here where we look at the inventory of 2 months and we're adding together. So let's say you're doing this in Excel or one of these programming languages. Then what you would do is you would add this the data and this cell by the data and this cell, data and this cell by the cell. But the logic behind it is basically just matrices. You convert the table to a matrix and then you do all the operations you want with it. And then later, once you're done, you can present it as a table, make it neat. So shop A, shop B, make it nice and neat. Total pens, total pencils. Okay, and then just copy it in 50, 56, 61, and 63. So once you're done doing all the you do all the calculations in matrices, then you convert it back to tables so it looks nice and understandable. So this is what this matrix means. Okay, so this is an example of addition. Go on.
You froze just now.
Oh, but can you hear now?
Yeah.
Okay. And now this is an example of addition. Now if you want to do subtraction, I'll give you an example. Let's say this is the total inventory for February. This is the total inventory for January. Okay. So assuming that nothing was sold or you're disregarding how much was sold, you want to find the number of additional pens that arrived between January and February. So then what do you do? You want to find a number of pens that arrived between January and February.
You froze again.
So can you hear now?
Yeah.
Okay. Let's say I want to find the number of okay. I want to find the number of items that arrived between January and February. Because February stock is higher than January, obviously, right? So how much arrived between January and February? What do I do? Think.
You add?
No. This is what we added just now to find the total stock between of the 2 months. But what do we want to find the difference?
Oh, you subtract.
You subtract which from which? Jan from Feb or Feb from Jan? You want to find how much stock arrived between January and February.
So, for that.
Yeah, you subtract Feb minus Jan because Feb is higher. So you do the same thing. You convert each to a matrix, so that will be 30, 35, 31, 32. Then you subtract it with Jan's data 20, 21, um, 30, 31. Okay, so now you do
Mm-hmm.
some basic subtraction of the corresponding elements. So that we just like 10, um, 14, I think, yeah, 14, 1, and 1. So basically, you can tell from here that for, okay, this is shop A, this is shop B, pens, pencils. So you can say that 10 new pens came for shop A and 14 new pencils came for shop A. But for shop B, only one new pen came, and then only one new pencil came. This is like very basic calculations with the with matrices. This is basically why we use matrices, to make it easier to visualize um, tables. Basically, just like you basically just convert tables to matrices. You calculate and convert them back to tables. That's the use of matrices. I think adding and subtracting, you already know, right? We don't need to go over it again. I'm just doing an example.
Yeah.
Adding and subtracting is fine. So now let's go to a few properties. You know what the identity matrices are? Did you cover this?
I don't think so.
Identity
But
matrix.
yeah, go ahead. I
Identity
think
matrix is
it's
1 0. This is the identity matrix. It's only one thing to know. So if it's a 2 by 2 matrix, then this is the identity matrix. If it's a 3 by 3 matrix, then this is the identity matrix. This is the identity matrix for 2 by 2, 3 by 3. It's basically just a combination of ones and zeros. Right now it won't make much sense, but later I'll explain why this is used. Next thing, the order of a matrix. No, an order is a. So let's say we have this matrix over here, okay? It's a rectangle, it's a rectangular matrix. So now they ask you to find the order of the matrix. What's the order of the matrix?
it's 2011, 2012,
No, no.
not 2020.
Order of a matrix means the shape. So shape, you can just put it as the number of
So,
rows,
so,
x columns.
so 3 by 3.
No, how many rows are there here?
3 by 2.
No, Ibo, think. It's the other way around. How many rows are there? Rows, cinema rows in the cinema. Rows.
2 by 3.
Yeah, it's 2 by 3. So there are two rows and three columns. Okay, there are two rows and three columns. So when they ask you for the order of any matrix, just put 2 times 3. No need to actually multiply 2 by 3, just put 2x3. It's just to call the shape of the matrix. Okay, now order very important for multiplication. So now let's try to multiply two matrices. For most basic levels, they won't ask you to. They only ask you to multiply 2 by 2 matrices. So keep it simple, keep the numbers small. Okay, these are two very simple small numbers. Okay, small number matrices. Um, um, for basic level, they only ask you to find the product of 2 by 2 matrices. So the order of both of this is 2 by 2. You all need to know. Okay, so there's actually there's one condition for multiplying. So let's say you have two matrices. Or one is like this, and the other matrix is like this. Okay, so now the first thing you need to do when you're given two matrices is to find the order of each matrix. What's the order of this matrix?
Uh, which one? The one on the left?
Yeah,
The 2?
2 by 2.
3,
And the order of the second one?
3 times 0,
No. How many rows are there? 3 is correct, fine. 3 is correct. There are 3 rows. How many columns are there?
1,
So what's the
3,
order?
3 by 1.
3 by 1. Yes. So in order for you to multiply the number of columns of the first matrix and the number of rows of the second matrix have to be the same. So for example, here we can actually do multiplication because the number of columns in the first matrix and the number of rows in the second matrix are the same. But here, the number of columns in the first matrix, number of rows in the second matrix are not the same. So basically, we cannot do multiplication for this. It's impossible, matrix wise. But
Mhm.
that doesn't mean that only similar looking matrices can be multiplied together. Even if you have a matrix like this, same 1 5 2 4, okay, but this time we're multiplying it by something like this. So the order of this matrix is
2 by 2,
and the order of this matrix
2 by 3.
2 by 3. So you can see here that the number of columns of the first matrix and number of rows of the second matrix are exactly the same. So basically
Mm.
multiplication is possible. And you know why this is important or why we need to check all this number of rows, columns and all that stuff.
You can't multiply uh, if it's not similar.
Yeah, if it's not similar you can't multiply. That's also another thing. Based on this you can tell you can actually find the shape of the product. So the first thing you're multiplying is 2 by 2. The
Mhm.
second one is 2 by 3. So the product will be 2 by 3 because you're cancelling off the number of columns here and number of rows here. We cancel it off. Then the final matrix, the product is the product of the leftovers 2 and 3. So now the product of these two will be the shape will be 2 by 3. So you have 2 rows and 3 columns. It looks similar to this, the product of this. Okay. Now
Mhm.
let's um, let's actually try to multiply. Random numbers. Okay, so first order of business, you have to determine the um, order of both matrices to determine whether you can actually multiply or not. So in this case, it will be 2 by 2, and this case will be
2 by 3.
2 by 3. Yes. Next, determine the order of the product. So you cancel off the columns here and the rows here. It will be 2 by 3.
Mhm.
Okay, so now let's actually multiply. This is the trickier part. In order to multiply, okay, let's say I want to find the first row. We already know that it's 2 rows and 3 columns. So we're gonna go we're gonna go row by row. So to find the first row and the first column, find the first row and the first column, we have to multiply the first row here, first row of the first matrix by the first column of the second matrix and add the corresponding elements. It will be 3, 1 times 3 is 3, plus 5 times 6 is 30, it will be 33. To find the second row and first column, we have to multiply the second row of the first matrix by the same first column of the second matrix. It will be 2 times
Mhm.
3 is 6, plus 4 times 6 is 24. So 6 plus 24 is 30. Now we want to find the first row and second column. So what do we multiply together?
So 1 and 5 is 4 and 7.
Yes, very good. So the first row of the first matrix by the second column of the second matrix. So it will be 4, 1 times 4, 4, plus 5 times 7, 35. So 4 plus 35 is 39.
Oh, I see.
Second row, second column, what do we multiply?
2 and 4 by 4 and 7.
2 and 4 by 4 by 4 and 7. So it will be 8 plus 28, 36. First row, third column, what do we do?
Okay.
Same concept. First row and third column is the first row of the first matrix, and the third column of the second matrix. That will be,
So 5 and 5 and by 5 and 8.
yeah, 5 plus 40. So it will be 45. 1 and 5 by 5 and 8. So the second row, third column, the second row of the first matrix, and the
So
third
it
column
can
of the second, yeah. What will it be?
40,
Tell me.
42.
42, 2 times 5, 10 plus 32. Yes, 42. Very good. It is 42. It's as simple as that. Multiplication. But you often get a very weird ones. For example, okay, we find something that's possible to do 1 by 2, 2 by 1. 2, 3, 5, 1, 2, 3. So first order of business, what do you do? What do you find first when you look at a multiplication question?
That's this is 1 by 3.
Okay, first one is 1 by 3, very good. The second one,
3 by 1.
so is it possible?
Yeah,
Why is it possible?
because 3.
Okay, the 3 is the same. So number of
Yeah.
columns here and number of rows here are the same. So what is the order of the product?
2 times 1, 3 times
No,
2.
what's the order of the product? I don't want the product, I just want the order of the product first.
Um, what do you mean?
The
Like,
order, so this is the order of this matrix, this is the order of this matrix. If you multiply these two together, what is the order of their product?
3 by 1. Oh, sorry, no.
Think carefully. I told you.
1 by.
Yeah, it's 1 by 1. Why? Because we're just cancelling off the columns here and the rows here. What I usually do is I box it, and then I just cross it off. So I can only see the number of rows here and number of columns here. So the order of the product will be 1 by 1. So now we already know that's only going to be one row and one column is basically just one value. So the product here will only be one value, that's it. So to find the first row and first column, which is the only value, we have to multiply the first row here by the first column here. So it will be just 2 times 1, 2. 2 plus 3 times 2, 6. Plus 5 times 3, 15. That will be 8 plus 15 is 23. That's it. Product is 23. For a one more example, I'll keep the number small. Okay, let's make it a bit bigger. Okay, how? What is the order of the first matrix? What's the order of the second matrix?
3 and 3 by 1.
3 by 3. This is 3 by 3. And this is 3 by 1. Is it possible?
Yes,
Why?
because there are three rows
3
on
columns here
each.
and
Yes,
3 rows here. Okay, box it. Cancel it off. So what is the order of the product?
3 by 1.
3 by 1. Okay, now let's actually start doing it. So now once you get the order of the product, you map it out first. You know there's going to be 3 rows. There's only going to be 1 column. So to find the first row and the first column, you multiply the first row here by the first column here. So 1. Oh, why don't you do this for me? Take a paper. You take a pencil and try this.
So it will be 1, 2. Wait, so it'll be 1, 2, 3 times 1, 2, 3, right?
Yes.
Yeah, so 11.
Okay, that means like 1 plus 4 is 5. No, see? 1. 1
Oh,
times 1
9.
plus 4 plus 9.
14. 14.
1 plus 4 plus 9 is 14, yes. Okay,
So I saw 3 times 2.
what's the next one?
So it will be 4, 10, 18, 28, 32.
14 plus 18, 32, yes. Okay, what's the last one?
21, 24, 27.
Okay, 23 plus 27. What is the answer?
72.
23 plus 27. Okay. No, 7 times 1 is 7, plus 8 times 2 is 16, plus 9 times 3 is 27. Because you're multiplying the corresponding elements, see?
16. Yeah, I times everything by 3 for some reason. So
7, okay.
50.
50. Yeah, 50. Good. Okay. So that's basically multiplication. Quite easy, right?
Yeah.
What else is there? Do you guys get asked about the inverse of a matrix and stuff?
Let me check. No, it doesn't look like it. No.
No, you don't. Determinant. Inverse means you don't need determinant actually, but still.
No, no. Doesn't, no.
Okay, so basically just the addition, subtraction,
Mm.
and multiplication of matrices.
Yeah.
Okay.
Yeah. solve matrix equations.
Oh, wait.
There can start and
Okay.
the
So now let's start with determinant. So are you with me so far?
yeah.
Determinant. Okay, so given okay fine. So for our level, for foundation level, you can stop with finding the determinant of a 2 by 2 matrix. So if you go on to degree and stuff, or not degree but higher levels and all, you might have massive matrices, 3 by 3, 4 by 4, and you ask to find the inverse determinant and stuff. But for the determinant of a 2 by 2 matrix, okay, I'm gonna put just 1, 2, 3, 4. Given a 2 by 2 matrix, you want to find the determinant of it. It's basically what do you call it? AD minus BC. Okay, what does this mean? If you map out all the elements in a matrix as A, B, C, D, to find the determinant of this matrix, you have to multiply, okay, the element at A by the element at D, subtracted by B times C. Okay, so what is the determinant of this matrix? Determinant, we write it like this. Let's say the A, this matrix is called A, and we want to find the determinant of A, we do AD minus BC, which is 1 times 4 minus 2 times 3. So what is the determinant? 4 minus 6. That's it. Determinant of this matrix is minus 2. It's just AD minus BC. Bro, are
Yeah.
you with me?
So
Hmm.
and then
Okay.
yeah, I get it.
Okay, just remember AD minus BC. Write it down somewhere or take note of this. Determinant, that's it. But they won't just, okay, look at the bigger picture. Determinant doesn't actually matter if you just do it just like that. Determinant is used for finding the inverse of a matrix. Determinant on its own pretty useless, but if you use it with inverse, it's actually pretty powerful. You can do a lot of you can go all the way to solving all the simultaneous equations and all just by using inverse of a matrix. So now let's find the inverse of that matrix. So given A, okay, I'm gonna put 1, 5, 6, 7. Just putting random numbers here, it doesn't mean anything by the way. Okay, so this is the matrix A, and we want to find the inverse of it. So to find inverse of a matrix, to represent it, we just put A to the power of minus 1. This means that this is the inverse of matrix A. The formula is like this: 1 over AD minus BC, which is AD minus BC is the determinant, 1 over the determinant, multiplied by DA minus B minus C. Okay, so let's say the basic matrix A, let's assume, take out the digits, the basic matrix A is ABCD. This is just ABCD. And then the inverse of this matrix, this is the formula. So AD minus BC is the determinant. 1 over the determinant multiplied by negating B and C and then switching the position of D and A. So assuming that the matrix A is 1, 5, 6, 7, which occupies A, B, C, D respectively, the inverse of A is 1 over the determinant, which is 1, 1 times 7 minus 5 times 6, and then the you negate B and C, which is 5 and 6, so that will be minus 5 and minus 6, and you are switching the position of A and D. So 1 and 7 switch positions, so they become 7 1. Okay, now you simplify 1 over 7 minus 30, which is minus 23, multiplied by 7 minus 5 minus 6 1. Then you just distribute to each element inside the matrix. 6 over 23 minus 5 over 23 minus 1 over 23. So this is the inverse of the matrix A 1567. So actually it's okay, we just stop here. You don't usually need to distribute, or because like if you distribute later on when you're doing higher level calculations and you're like working in matrix equations, then if you distribute, the numbers get very complicated to add and subtract later. So now, for now, you can leave it like this. But if the question is just to find the inverse and nothing else, you can actually distribute the factor outside. This is the inverse of a matrix. So how's it so far? Mm,
Just for anything, if you're just AD minus BC,
mm.
like 1 over AD minus BC, and then, yeah, I think I did it.
So the logic is pretty much the same for just about any 2 by 2 matrix. Okay. So now, um, let's look at an example of where you would use a matrix equation. How about you give me a question? Give me one of your matrix questions where you have this equation stuff. Then I can explain.
Uh, I mailed you the question sheet, or I'll screenshot it and I'll send you.
Mm.
This is this isn't very good on paper that I just did. It is done betray Underwood in the series. Uh,
Done? Who's done? Which done?
huh?
Which done?
Doug.
Doug. I need to trim all
Hmm.
this out, if I upload this, but I think no. They have some hostilities, but once Underwood becomes president, then um, they have some kind of issues, definitely. But he doesn't go to the extent of betraying all, like completely. Okay, coming back to the
Did you see the question?
let me see.
Did you see on Google homepage? There's like a black ribbon.
Yeah, it was a few days already. Oh, I can actually paste it in. This is nice.
Huh?
Can you see the question?
Yeah.
Okay. Um, so basically, like the part A, B, and C, we'll do that later for practice. What I want to focus on is part C. So we have working on part C. We have this question here: x times 3 minus 2, 4, 1 is equal to 5 minus 3, 2 minus 4. Then you want to find x. So usually when you want to find x, you move everything. You basically just isolate x in one side, right? You move everything to the other side. That's how you usually do it. Right, Ivo? It's the same concept here. But this time when you're moving this entire matrix here to this side, so I can just leave x over here. When moving it to the other side, I have to move the inverse of this matrix. I can't just subtract it off on the other side. I can't divide it. I have to when I move it to the other side, I am moving the inverse of it. Just like let's say we have x plus 2 is 3. When you want to move the 2 to the other side, you are subtracting it off. Right? You have to change the sign. Remember, that's the principle of how it works. So when you move 2 to the other side, you change the sign. So plus becomes minus. Let's say it is 2x equals 3. When you want to move 2 to the other side, since you're multiplying here, you have to divide the other side. So it becomes 3 over 2. Same concept here for matrices. When you move a matrix to the other side, you have to move the inverse of it, not the matrix itself. So here x will equal to 5 minus 3, 2 minus 4 multiplied by the inverse of this matrix. So 3 minus 2, 4, 1 to the power of minus 1, which signifies that we want to find the inverse of it. Okay, so now when you want to find, okay, let's start with finding the inverse of this 3 minus 2, 4, 1. So I'm gonna leave that there because it doesn't change anything now. And then let's find the inverse of this matrix. So what's the first step? Remember the equation? Okay, 1 over AD minus BC. So A is 3, D is 1. So 3 times 1 is 3, minus minus 8. So that will be 3 minus 8. Okay, That will be A and D switch. That will be 1, 3. Then minus B minus C. Negate B and C. That will be 2 minus 4. So I'm going to keep the other matrix on this side. And then I'm going to clean this up. So 1 over 3 plus 8, 11. 1, 2, minus 4, 3. Okay. So now we have x is equal to this matrix multiplied by this matrix. So okay, almost there. We're almost there. The problem is we have this 1 over 11, which is quite annoying. So what happens is if I go and distribute this right now, I go and distribute this to every single element right now, and then I do multiplication with this. Trust me, the steps will be crazy. It'll be very complicated. We have to use the calculator and stuff. So to keep it simple, what we usually do is we move that factor to the start. We multiply these two matrices first, and then only do we distribute the 1 over 11. So in case you're confused, let's actually do that. Let me clear this off.
Okay.
Still haven't figured out how to do some erase an entire section of the page without doing it manually. Like I can actually delete the entire page and then start over fresh, but I haven't figured that out yet. Okay. Let's start here, okay? So let's have the 1 over 11, 1, 2, minus 4, 3. Okay, so the first thing we do is 1 over 11, we're going to move it to the start because we want to multiply the matrices first, then distribute, so it makes it easier. So I want to move 1 over 11 here. Then I'm going to put the two matrices side by side. 1 minus 4, 2, 3. Okay, and then I'm going to do the proper multiplication of these two matrices first. So leave 1 over 11 there as it is. Leave it as it is. Then do cross multiplication. This you know how to do, right? The first to find the first row and first column. The first row here multiplied by the first column here. Second row first column. Second row the first matrix multiplied by the first row. First column the second matrix, and so on. So same concept. I'm gonna do it quickly. So what is the do it?
Uh, 5 plus negative 20.
5 plus 12. 5 plus 12 is 17.
Huh? Oh, okay. Sorry. 5 plus 12.
5 plus 12 is 17.
Mm.
And then the
4 minus 12.
you're talking about
Sorry, plus minus.
the first row,
Yeah.
second
Uh,
column.
it will be negative. Yeah, what would it be? 4 and 12.
No. What do you which row column are you talking about? First row, first column. First, second row, first column.
The second column.
First row, second column. You mean okay? First row, second column is
Well, I'm a bit confused.
okay. Go back to basics. To find the first row and second column of I'm gonna put the label it 1 2 1 2. To find the first row and second column of the product, we have to multiply the first row of the first matrix by the second row of the second matrix. I'm sorry, of the first second column of the second matrix. To find the second row first column, second row of the first matrix by the first column of the second matrix. So if you want to find the 1 1, first row first column, 2 1 second row first column, 1 2 first row second column, 2 2 second row second column. You understand?
Hmm.
Okay, so now what's first row second column?
5 and 2 and 3, right?
5 um 5 minus 3 and 2 and 3, yeah.
Yeah. So it'll be 10
Mhm.
plus negative 9.
Which is
1.
x. Very good. Next, second row first column.
So it will be 2, uh, 2 plus 16, 18.
Okay. And second row second column.
6 plus negative 12.
6. 2 minus 4 times
4,
2 3.
4, 4, 4 plus negative 12.
Which is
Negative 8.
negative 8. Okay. Okay, now you have to be careful, Ibo. You have to practice a lot when it comes to multiplication and matrices. Later on, you won't have to put the label, the rows and columns. You can straight away do it. But until then, you have to do a bit more practice until you can decide which row to multiply with which column in the product. Remember the pattern. If you want to find the first row first column, you multiply the first row of the first matrix by the first column of the second matrix, and then so on in that pattern. Okay, anyway, so now that we have multiplied these two matrices together, next step we have that 1 over 11 here. Basically just distribute it
Yeah.
throughout the
So it will just be like 17 over 11,
17 over 11.
18 over 11, 1 over 11, negative 8 over 11.
Yep, that's it.
That's it.
That's about it for for the inverse, and then basically we just solved an equation using matrices.
Mm.
Hmm.
Can I take this picture?
This whole thing is being recorded.
Mm.
Yeah, you take a screenshot. Take a screenshot. Okay. Okay. Now I think we've covered everything we need to know. Let's try 6A, B, and C now. So
Okay.
I mean,
Oh yeah. I asked a past student
hmm,
what subjects, like what math subjects are like important for project management.
hmm,
He said statistics,
hmm.
probability, and distribution. They were like the main three.
This is statistics, by the way. This is a part of statistics. Or it will be like hmm, yeah, you'll be applying matrices quite frequently if you do higher level statistics, because like statistics are a way of organizing data, like whether it's tabular data, um, or let's say you're doing a survey and then you want to look at all the numbers as a whole, do some basic calculations. Matrices will come into play, but not that important, but still something you need to know.
Mm.
Hmm.
Okay, so A plus B.
Okay, let me just erase this off while you do it so I can also do it. I want to make this eraser bigger. Show the lagoon. That's it. This is big. Oh, oh no. Oh, actually, I shouldn't have done that. Increase the size a bit.
You can't just clear like what you've written.
I can clear off the entire screen and restart, but if I
Mm.
wanna erase off sections, basically if I actually as a matter of fact now, why can't I do that? Because it's only the image I want for which I can paste later. There. Can hide all the toolbar, lagoon, other stuff.
Do you pirate this or does it
No,
come
sketchbook is
with
free. Hey, this is YouTube, right? Don't review all the stuff.
it?
No, by no. Sketchbook is free. Sketchbook is 100% free. It's open source. No, not open source, but it's free.
Yeah, one you might
Hey,
you
hey,
have
hey,
that.
waiter, what is waiter? Once I stop recording.
The thing will apply for this as well, right?
Yeah, same rules.
The 2 by 2.
Okay, wait.
No,
Here's the trick. Look at question A. Is it even possible?
no,
Why is it not possible?
because there's no common.
Okay, I forgot to say this. For addition and for multiplication, there's a special pattern, right, where the orders must be like columns and rows must be sort of like the same thing. But
Mm.
for addition and subtraction, if you're adding and subtracting two matrices, the order of both should be exactly the same.
Just as you said 4 and you froze, I didn't hear anything you said.
Okay, okay. Um, so for multiplication, there's a specific order, right? As in like the columns of the first matrix, the number of rows of the second matrix must be the same, right? Bo?
Yes, yes.
Okay. For addition and subtraction, the order of both matrices must be exactly the same. So a 2 by 2 can only add with 2 by 2. A 3 by 3 can only add with 3 by 3. A 2 by 3 can only add with 2 by 3 and so on. So
Yeah, so
when
this, yeah, so,
so it's not possible. Hmm. So is A plus B even possible?
no, it's not.
It's not
It is not possible.
not possible. But this is possible,
And
right? 1 over
yeah,
4 times A.
1 over 4 times A, uh, this what is this means like this 1/4
Hmm.
just times this.
Times 2 minus 3 a minus 6. This is how it looks like. So what do you do?
So just multiply, right?
You distribute to each one. Yeah, you just multiply. Distribute. That's it. Simple as that.
So it'll be 1/2.
1 over 2. 1 over
1
4a.
over 2.
This one is
Uh, -3/4.
and this one.
Um, -3/2.
Yeah, that's it.
Oh, maybe not.
That's it. Very easy. 2a minus 5d. Slightly harder, but still doable.
2a minus 5, it's like just, so basically, first do you have to multiply 2 times a
Yes.
and times b?
5 times d. Then you subtract the 2. So it looks
Oh, I
something like
see. Okay.
this.
Okay.
2. 2 minus 3. A minus 6. Minus 5. 2. 19. 12 minus 7. And distribute. 4 would be 4. Minus 6.
4,
2a
6,
minus 12.
minus 12,
Minus
10,
10.
-10.
Yeah, 10.
Oh,
Just no, don't
uh,
ignore the negative now.
okay. Um,
95, I think. 19 times 5 is 95. Yeah. 60 minus 35.
3,
Okay. Then you subtract the two corresponding elements. It will be minus 6. Um, minus 101. 2a minus 60. And minus 12 minus 35. So that's like minus 12 plus 35. Minus 12 plus 35. 35 minus 35 minus 12 is 23. Yes. Yeah, 23. Sorry. 3. That's it. Minus 6 minus 101. 2a minus 60 and 23. Yeah, I think that's about it for matrices. The bulk of it we already covered. So summary, we did addition, we did subtraction, we did multiplication, we did factoring. This is factoring. Basically, this is a factoring. We multiply a common factor to the matrices. We solved an equation using matrices. I think that's about it. There's also another step you can go. It's like an extension of this, where you can solve simultaneous equations using matrices. Do you guys do that?
no, not right now.
Not right now. Okay. Then that's about it. Let me stop recording.